Greetings from National Water Academy, and a very warm welcome to all the participants and our respected faculty for this WMO Basic Hydrology course, which commenced on 3rd October and is going to conclude on 17th November with a concluding webinar on 21st November. So these are the last 2 weeks of the webinar, our course, and for the last 5 weeks we have seen that there have been little issues and queries related to the course. So we thought that it would be appropriate, because these 2 weeks are very important, where you have to complete your remaining modules and you have to complete your final writing assignment. So these 2 weeks are very important, and you have to, whatever is lacking, we have to complete it. And to assist you in that, we thought it appropriate to conduct a webinar in which any kind of queries you have, you can raise, and our experts will answer that. We have Mr. M.K. Mathur sir, a renowned hydrologist nationally and internationally, and our former member, Central Water Commission, which is equivalent to additional secretary rank. And we have Matt sir from WMO helping us in this webinar. We have our head of academies, Mr. D.S. Shaskar sir, chief engineer, who will also be guiding during the webinar. We have already 28 people who have joined, and I think I would invite Mr. D.S. Shaskar sir to commence the proceedings. Welcome, sir.
Thank you, Pandeyji, and I must compliment Shailendra Pandeyji, who is the course coordinator, for conducting this webinar at a very appropriate time, because we already are in the 6th week of this training program, and the program will conclude in the next week, and it is a right time to seek guidance from our expert faculty in respect of any queries, any doubts, any questions. And I'm thankful to Shri M.K. Mathur sir, who is so kind to not only he was guiding during the course of the training program, but today he has joined live to interact with all of us. Dr. Matthew Kelch, who is a hydrometeorologist, who is associated with WMO and National Water Academy programs since 2012, for the last 1 decade, more than a decade. It's really a pleasure to have him in this webinar as well. Many of the comment modules, he is associated with the development of those comment modules, and if there is any query, question, doubt on those modules, he is the right person to ask about it. We started this program on 3rd of October, and we have completed 5 weeks. This is the 6th week going on. The weekly assignments that were there have been completed by many of the participants. It's really heartening to see the grade book full of grades, and many of them are 100, 90. So when I take a look at the grade book, I really have a sense of satisfaction that most of the participants are doing really well, and it is a sign that the course content has been designed very nicely, and they are able to understand it. As we always see during such distance learning programs, participants are a bit hesitant in asking the questions on a course forum, and that is why we thought of having this webinar, whereby our faculty will be available and people can ask questions live to them. We have collected some of the questions. We will go through those questions first, and then we will request the participant to ask questions through live questions. The question can be put forth through the chat box, or you can unmute yourself and speak. Both the options are available to you. Once again, I welcome our expert faculty. It's really one of the faculty who is also a writer of the NWA modules, Shri Anup Kumar Srivastava. Because of some urgent work, he was not able to participate in this webinar. But I'm sure if you have any queries, we will certainly convey the queries to him. Very specific queries which he needs to reply. We can convey the queries to him and we will get the answers. In fact, this is the first training program, distance learning training program, in which apart from the opening webinar and the concluding webinar, we are having an intermediate webinar. We thought of interacting directly with the participants so that there is a close contact and face-to-face interaction between the faculty and the participants. And we also had one recording included in the third week of this particular course, and this recording was a recording of a live lecture which was delivered by Sri Anup Kumar Srivastava on measurement of river discharge. So we were having the recording available. So instead of having the live lecture again, which were actually trying to have a live lecture, but because of the unavailability of Dr. Srivastava, we put the recording, and I hope, as I can see, many of you has actually gone through that. When I see the activity chart, it shows that this particular recording has been seen by many people. And if there are any participants who have yet to see this recording, I would advise them to see it. It's a very enlightening lecture on measurement of river discharge. So with these opening remarks, and I welcome once again all the faculty members and participants, and request Master Staff to give the remarks to begin with, and then Mr. Matt can speak, and then we will take up the questions one by one. Thank you.
Thank you, Jasper sir. It is a good opportunity to interact with all the participants, and participants are free to ask any question. Whatever questions they have collected, that we will answer, and if there are other questions also, they can ask live, and we will try to accommodate as many as possible. And if something remains, then we are connected with WhatsApp and emails, so we can you can always ask those questions. So this is a good opportunity to meet face to face and interact with each other. It should be a two-way interaction. So I appeal to you that you also, without hesitation, ask or comment on any topic. Thank you.
Thank you, sir. And now I request Matt sir to say a few words in the beginning.
Good morning and good afternoon, depending on where you are. Many of you have become familiar with my name because I've been using the forum quite a bit over the last 5 weeks to speak with you, and I congratulate you on your efforts to date and look forward to seeing the written assignments that you do. As was introduced, I was involved with the development of the COMET modules. I am a meteorologist by background, not a hydrologist, but when those modules were developed, I worked with hydrologists in the field so that we could develop a basic hydrologic sciences course. That was initially done with the National Weather Service in the United States and then expanded for a global community. So while I won't call myself an expert on all the topics in those modules, I am familiar with them, some more than others, and I hope you found those useful. So I will turn it back over to my colleagues, and we will take your questions if you have any. And again, even after this webinar, if you have questions for any of us, please use the forum. If you have any questions specifically for me that you don't want to use the forum, feel free to message me through the Moodle messaging system.
Thank you, sir. Thank you very much. And can we begin with the questions we have already received or identified, and then it can take up, or should we wait for participants to speak up first?
I think there is only one question right now in the chat box, which I think we can take it. It is about how do I access my post-grade book. The post-grade book can be accessed if you go to the menu in your in the course website after you log in, there is one link called grade. If you click on the grade, it will show you all the grades that you have received in various modules. If you want, I can share my screen so that you can I can point it out to you. So I'm sharing my screen. As you can see here, if you see this on the left hand side, there is participants, badges, and grades. If you click on the grade, it shows you here the list of the all modules and the grades that you obtained in each of the modules or each of the quizzes that you have taken. So I hope I'm clear.
Yes, sir. Thank you, sir.
Yeah. Okay. Welcome.
So, sir, I was asking whether we should take up the questions we have identified, and we had received one question in course forum also. We should take up that first, and then participants can raise their queries, or the participants should raise their queries first.
I think we can take
Sir, in my view, you project these questions,
Yes.
but if the person who has raised this question is present, then better it will be that he raises that question and
Yes.
then we answer. And if the participant is yet to join, then we pass on that question.
Sir, actually we noticed that many want to be anonymous while raising the questions, so I have collected those questions.
Okay.
But
Then it is better that
it is always welcome respect to if they can speak up and raise here. I will just show the PowerPoint to the questions one by one, and anybody really directly question or related to that question something wants to ask, they can raise, and apart from that also whatever they want, they can raise their hand and speak up. So should I share the question, sir, as PowerPoint? Sure. So, sir, we had this question to use log Pearson's method to calculate flood discharge using the type 3 distribution approach. The variance of regional skewness, which is taken to be 0.302 for the US, is it also applicable in India? I am unable to figure out the skew coefficient. Please explain. This was raised in course forum, sir.
Matt would like to speak or I can speak?
No, this is not my expertise. I would appreciate if you could answer.
Okay. So, first thing first, log Pearson type 3 distribution is prescribed in USA by various states for flood computations. In India, we do not have any such prescription for the method which we use. It is based on the choice of the hydrologist, that based on the data, they fit the appropriate distribution for determination of a particular return period flood. That is the first thing. Second thing, not only we do not have any prescription of the distribution, we don't have any prescription of the method also. For example, in USA, they prescribe a particular method that is called a WRC method, where they prescribe that you should first take the logs and then only method of moment should be taken. Here, we do not have the prescription for the method also. So it is the statistician's choice whether he applies it by method of moments or method of moments on log of the parameters or anything. Third thing, while most of the methods which are two parameter methods, like our Gumbel's distribution, they have got a definite skewness, that is 1.13 for Gumbel. So if there is a skewness in your data, you can compare whether it is 1.13 or not. If it is 1.13, nearer to 1.13, we directly apply the Gumbel's distribution and say that this method is likely to give better results than others. If it is not 1.13, say it is 2 or say it is 0.5, then we can apply some transformations on the parameters. That is called box-box transformation, is one of the most recommended transformations, so that we bring this skewness to 1.13, and then we can apply the Gumbel's distribution. Pearson type 3 distributions, log or no log, are 3 parameter distributions. 3 parameter distributions do not have any specified skewness or parameters. There are parameters like A, B and C, and there are constraints, and those constraints with the fitting of the equation A, B and C, we find out the parameters A, B and C, and then it defines the frequency distribution. What we are saying 0.302 is only a value found by most of the floods in those regions in the data set, and that is why US specifications mention it, that this skewness CM can be 0.302, which is a regional variance. Variance is a regional variance of 0.302, and one can see the data that it conforms to that regional variance, or like that. In India, it is not prescribed. We have to test our data on our own and justify the method of fitness.
Sir, related to this question, there are two questions which have come up in the chat window. If you can kindly see it, sir. The questions are from Pallavi Datta. The first question is, while doing hydrodynamic model for the calculating the peak discharge, is it safe to use only Gumbel's method?
Hydrodynamic model is a physical model, and so there is no question of statistical methods like Gumbel method or everything. Hydrodynamic models are mostly physical models, so there is no question of Gumbel's method. Gumbel's method is a stochastic model, and based on the various peaks observed in different years. So the two cannot be compared, two cannot be taken together.
Sir, but in our case, sir, in Assam, the Diavarali study, the hydrodynamic model is done based on numerical process in HECRAS.
Agreed. So HECRAS is a hydrological model, and it takes the rainfall and converts it into runoff. So there is no question of Gumbel's method or any method. If you are putting up a 100-year intermediate flood for that outing, then that 100-year period flood, whether you compute from Gumbel's method or log Pearson method or any other method of your choice, that is the justification to be given by you. But HECRAS doesn't have anything to say why you have put Gumbel's method or this method. For them, that is only a particular flood. Maybe it is a 100-year return period flood, maybe it is an SPS, maybe it is a dam break flood, or whatever is the flood that is routed by the HECRAS and taken to the point of interest.
Okay, that means the process that we use makes no difference. Whether we use Gumbel's method, whether we use
makes no difference. Whatever is the input, that will be the output. If it is an SPS, then SPS will be the flood corresponding to SPS will be the output. If it is a 100-year return period flood computed by Combos method, then it will be 100-year return period flood as output. If it is a 100-year return period flood log Pearson type 3 input, then the output will be again a 100-year return period flood based on the log Pearson method.
Okay, sir. Thank you.
Okay, so there is one more question from Pallavi Datta. While doing quantitative precipitation forecast, what is the guideline for grid spacing?
This is actually decided by India Meteorological Department, and usually India Meteorological Department is giving quantitative forecast at 1 degree grid interval, but I think now 0.25 degree forecasts are also available.
Of course, the answer to that question is going to depend a little bit about how you're using the forecast. If you live in a country that has a lot of topographic features where there might be a lot of variability in precipitation, you may choose to do a higher resolution precipitation forecast, even though it may take up more computer resources. If you're using a distributed model, you may depend more on that high resolution precipitation forecast compared to if you're using a lumped model where a somewhat lower resolution may be sufficient. So I'm not aware that there is any specific guidelines. Again, it might depend on how you're using those forecasts, what kind of model you're using, and what kind of precipitation variability you experience in your region.
Correct. And particularly regarding Assam, most of its input is coming from Arunachal Pradesh, which is a hilly area. So a closer grid interval would have been better, but with a caution, because in Arunachal, the physical rain gauge stations are very less in number. So even the grid extrapolation is also to be taken with a pinch of salt. However, nowadays they have put radars, weather radars, and therefore their quantitative forecast grid has improved.
Okay, sir. Thank you.
Thank you, sir. Can we take up the next question?
Yes.
Sir, it is about operational hydrometeorology to support WRM in India. Or in US also, Matt sir can pitch in. So I would request Master sir to say something about this.
Let Matt explain it for US, then we will come for India.
Okay, I'm not clear what the question is.
But how do you do the hydrometeorology in your country? That is the question. What you do?
Hydrometeorology is a big topic. In the United States, the National Weather Service is composed of weather forecast offices which forecast the different types of weather, including precipitation, rainfall, and snow. But it also has river forecast centers. That's part of the National Weather Service. And they are tasked specifically with taking the precipitation forecasts, the temperature forecasts, and generating river forecasts, river levels and river flows, as well as reservoir inflows and reservoir levels. So these two parts of the National Weather Service work together to produce those weather and hydrologic forecasts. And then they also work in partnership with other agencies that manage the dams and manage the different commerce that occurs on the rivers. This would include the United States Bureau of Reclamation, the United States Geologic Survey, and the Army Corps of Engineers that all have a hand in managing water resources, in particular dam operations throughout the United States.
In India Meteorological Department is the coordinating agency for hydrometeorological operations, and it works in close coordination with Central Water Commission, which is the agency for hydrological operations. And then there are various boards which manage the dams and everything. The first input you all must have noted comes at around 31st May, where India Meteorological Department, based on its regression model, gives the first estimate of how this year's monsoon will be, whether it will be normal or below normal or above normal overall in India and in various regions. So that gives the water planner an idea whether they should go for at ease with the water management, or they have to tight their belt for water management, because it is going to be a bad monsoon. So from there onwards, India Meteorological Department handholds the water resources manager. Then it comes quantitative forecast and progressive status of monsoon and various advance warnings of storms and all those things. So there is a day-to-day basis. Operational hydrometeorology works in tandem with water resources managers.
Thank you, sir. Thank you very much. We will take up the next question now. The question is, sir, I have two questions about the rainfall station. What is the radius of coverage area of the rainfall station? If I have a project in a catchment, but there is no rainfall station available inside the catchment, can I use the data from rainfall station from outside of the catchment for my model? Is there any minimum range location of the station to be used? This was the first part, and the second part is, if the catchment area is big, say 1000 square kilometer, but there is only one rainfall station located at the upstream of the basin, is there any suggestion on how to improve the rainfall data of the catchment for the design rainstorm? These are, sir.
Do you want me to answer that one?
Both of you, sir, can speak one by one.
Okay, first Matt can answer, then I will.
So the real answer to number one there is a rain gauge is only representative of its immediate environment. But of course, we need to use them, as they're often the only data we have, as approximate to the rainfall in an area. Now, among the tools we could use to increase the utility of rain gauge information are remotely sensed precipitation. Here we call that multi-sensor precipitation. So we might have something like a radar or a satellite that gives us rainfall information, and we use the rain gauges as point truth to help us calibrate the radar and the satellite field. So think of it as the rain gauges, which may be sparse, as says in the question here, there are not that many. The rain gauges offer a ground truth, while radar or a satellite, whatever you're using, can help fill in the aerial coverage so that you could get an estimate over a large area, a large basin. Even if the rain gauge is outside your basin, the combination of remotely sensed precipitation and rain gauges can give you more of a large scale coverage of rainfall. There will be errors with that. And also the utility of a sparse rainfall gauge will vary depending on the topography and the type of precipitation. So what I mean by that is, if you have stratiform precipitation, just a few rain gauges may be sufficient. However, many of you in this course are from countries that are in the tropics or semi-tropics, so you don't usually have stratiform precipitation. You usually have convective precipitation, where there's a lot of local variability. Again, that's going to make it real important to complement your rain gauge data, your sparse rain gauge data, with something remotely sensed. Topography will also increase the variability of rainfall, again putting limits on how much use you could get from a sparse rain gauge network. In the United States, many weather service offices use a program called PRISM, which is just guidance of the climatological expected rainfall. So if you look at PRISM, you will see mountain areas may get more rain than valley areas. And if you just have rain gauges in the valley area, they will use that rain gauge information but adjust it upward when you go into the mountains as an estimate of the orographically enhanced precipitation. So to summarize what I'm saying, rain gauges are only truthful to their immediate environment, but they can be used to get precipitation over a larger area with other tools of climatology, satellite-derived precipitation, and radar-derived precipitation. Turn it over to my colleague at NWA now.
Yeah, I will like to supplement what Matthew said. I was dealing with the hydrology of Arunachal Pradesh, where there were only 2 or 3 IMD stations in the entire one Bomdila and one Pasighat. So what do I do? Fortunately, the TRMM, that is Tropical Rainfall Measurement Mission of USA, that came to my aid. So I used to find out the aerial rainfall using the TRMM. But while doing that aerial rainfall using TRMM, I also used to find out the value at that particular station, like Pasighat or like Bomdila. And for that, I used to have a point rainfall from IMD. And if there was some difference between the two, I used to apply the bias correction on the aerial rainfall. So this is one of the practical approach which I did using the aerial product, the radar product, and the point rainfall. Having said that, all these radar products are from USA or other countries, and India's radar products are under development. So the classical approach that IMD has followed in India is that there is some old prescription from WMO about 1 in 1000 square kilometer in plain area and 1 in 250 square kilometer in hilly area as a prescription of how many rainfall stations should be there. That has placed in IMD manuals also, and people are following that. Second thing is that while what should I say? Second thing is that there are 2 types of hydrological outputs that we take. One is called water availability. In water availability, we deal with the aerial averages. But in design set, what you have written, 1 in 1000 or 1000 square kilometer or that, in design set, we are more bothered about the point rainfall which has occurred in that area, which is maximum, and can that be transposed to the project site. So there we don't do the averages. We take the sediment which is widespread. We draw the isoids. If it is 1 in 1000, if your catchment area is 1000 square kilometers, then for that 1000 square kilometers, we either take the depth area duration depth for that storm, or we transpose that storm over our project catchment and find out the aerial depth. We need not have any rain gauge station in the catchment if there is a storm in that area and that is transposable to our project site. Again, if we are going for water availability, where we have to take the average rainfall, and if we do not have sufficient number of rain gauge stations within that, Indian Meteorological Department has got a product that is called grid rainfall. This grid rainfall is available freely on Indian Meteorological Department site and very long term, right from 1901 year to 2022, just December, and after this December 2023 will also come. So we have got a long-term series of more than 120 years for every grid point. Grid points, they have got a coarser grid of 1 degree and there is a finer grid of 0.25 degree. So even 0.25 degree grid is a bit coarse because it is around 625 square kilometers. But if nothing is available, that is the best available data set to analyze the rainfalls. So I hope I have covered both these questions.
Thank you, sir. Thank you very much, sir. There is a query in chat box. Perhaps Matt sir can answer that. Sir,
California.
Recently in California, there was heavy rainfall which caused heavy flooding. My question is, what precautions, measures were taken to revert situation to normal? It is in chat box, sir.
Yeah, I read it, and I think the person may be referring to the very unusual rainfall associated with Hurricane Hillary. I should explain, California tends to have dry summers. Their precipitation tends to come in the winter. A few times a century, a hurricane makes landfall in Mexico and moves northward into California. And that happened this year in September, causing unusually heavy rains for the warm season. So the precautions taken, first there were evacuations and warnings put out, especially in an area that recently had wildfires. Fire is something that occurs many times in the western United States and could increase the chance of rapid runoff and debris flows. So they moved people out of harm's way. Typically with heavy rains, there's also decisions that have to be made about reservoir levels. Because this happened in the summer and reservoirs are already low, that wasn't a big problem for this particular storm. In fact, this particular storm was very helpful at putting water back in the reservoirs. The bigger problem is in the winter time, which is their rainy season. Some of the precautions they take and things they have to deal with is if a reservoir is full and a big storm is coming in, Weather Service and hydrologic forecasters have to work with the dam operators and the reservoir operators because it's possible they may have to make space in the reservoirs by releasing water so that they could capture the new water coming in. They don't want to release too much water because then that's water that's not available for agriculture and hydropower generation. But if they don't release enough, there's a risk of the dam overtopping in a very major rainfall event. So one of the things forecasters do in California in the winter is they categorize the storms coming in on a scale of 1 to 5, where 5 is the worst, 1 is weak. And if you have a storm that's categorized as 4 or 5, there are precautions that the reservoir operators have to take making space in the reservoir by releasing water. And it's not just the size of the storm. Another important factor in California, and this is probably true in parts of Central Asia where you have colder climates, is whether your storm is going to be rain or snow. Rain is a bigger problem in that it runs off immediately. Snow is easier to deal with in that it doesn't run off immediately, so you have a longer period of time to accommodate and plan for the runoff. So those are all the things that have to take place. But again, the one I think that's being referred to here, the recent storm, was an unusual summer storm, so the reservoirs are already low and there was no snow. So they dealt mostly with the short-term flash flood aspects of it by getting people out of flash flood prone areas.
Thank you, sir. Thank you very much. I hope this has helped the participants. And next query is about excess precipitation and base flow. So how to calculate the excess precipitation or rainfall for creating a unit hydrograph for any basin. And also, if we don't have hourly rainfall data, how to create the unit hydrograph of the specific basin. There are many methods available for separation of base flow, but I want to know which method is most appropriate for any river basin. Please explain. Matt sir, would you like to initiate or Mathur sir?
All I know about unit hydrographs is what is in the modules. I have never actually worked operationally deriving unit hydrographs, so if your colleague there can explain it better, I think I will turn it over to you.
Sure, sir. Mathur sir, please.
Using unit hydrograph, there are two types of operation. One is that we have got a observed flood, and out of which we want to derive a unit hydrograph. And another operation is that we have a unit hydrograph and we want to convert into a design flood. So this question is on the part first. That is, while deriving the unit hydrograph, what should we do? In an ideal world, I will want to have entire period of hydrograph at hourly interval and entire period of rainfall distributed hourly. If those two things are there, then there are so many possibilities there. One possibility is to deconvolute, what is called as Pauline's method, and this should give me unit hydrograph by deconvoluting the observed flood hydrograph with the observed hourly rainfalls. But this is not to be there. In India, data position is very bad. Hourly rainfalls are available only at one particular SRRG. It may not be in the catchment where the flood is being observed. And even when you try to match the observed rainfall with observed runoff, you may find that observed rainfall is only 100 mm and observed runoff is 300 mm because of all these errors in observing the data and everything. However, you have to choose the appropriate floods, more or less isolated floods with isolated peaks, intense peaks, where only 1 or 2 hours intense rainfall is observed, and for that some flood is there. If it is a compound event, even then we should try to focus only on a particular intense short duration flood event, so that our method of deconvolution does not go haywire. Then we have to subtract the excess precipitation and this base flow from this observed flood, so that rainfall excess and the direct surface runoff observed, DSRO observed, can match. It will be a reiterative process. First of all, try to find out a base flow line where the flood hydrograph has started rising, and join it where it has come to. Again, a respectable level, after which it has become flat. Join them even directly. There are so many methods available, but because the base flow may be only less than even 5% of the total peak, the highest peak in the event, so it may not matter much which method you are using for base flow. For that DSRO, that is direct surface runoff, try to find out the losses in the rainfall, how many inches of, how many centimeters or how many millimeters of the loss will balance. Again, when you will do that, some of the coordinates will go in negative, some of the rainfall axes will go in negative, make them zero. Then again change the base flow, again change the loss rate, again change the base flow. Iteratively we can do to find out a reasonably coherent loss rate in rainfall and a reasonably coherent base flow in the flood hydrograph, so that the rainfall excess volume matches with the rainfall, matches with the direct surface runoff of the.
Thank you, sir. The next query is how to average out the base flow within the basin or sub-basin.
I don't think there is any average out of the base flow. Base flow is at a particular point, so there is no question of average outing the base flow.
Right.
It is at a particular point of observation where there is a flood. Out of say 2000 cumecs of the peak, there may be 200 cumecs may be the base flow and 1800 may be the direct surface runoff. This query may have come out from the method of prescription of base flow. When we are doing the design flood hydrograph, we find out the design storm, out of which we subtract the loss rate, and then we convert it in the unit hydrograph, so that we get the design direct surface runoff. In that design direct surface runoff, we add the base flow. Now at that time we do not have any data for the base flow, so we have prescribed some 0.05 cumecs per square kilometer of a base flow. That is only a prescription, only a method, only a prescription, so that something can be worked out, which is not much significant, and that is based on the per square kilometer, and therefore you may think that 0.05 cumecs is average base flow per square kilometer. No, it is not average base flow per square kilometer. That is giving some 100-200 cumecs and do away for it and concentrate more on 2000-4000 cumecs.
Thank you, sir. And the next question is a very interesting question. Main purpose for which unit hydrograph can be used in modeling of river valley projects?
Simple flood computations. Unit hydrograph is a response function for a catchment, and once you have got a excitation in the form of rainfall, it can be converted into flood. So if you are giving a static design storm, it will convert into a static design flood. If you are giving it a dynamic rainfall on real-time basis, it will compute a dynamic runoff forecast in that basin.
Right. Thanks. And then next question is on runoff process. What is the impact of time of concentration in rational method approach used to access the peak discharge for small basins? Although there are many formulas available to compute the time of concentration, which formula has more reliable value and why so? And the next part is how much time of concentration should we adopt to use rational method approach for modeling of small basins? Matt sir will initiate or
Yeah, Matt can initiate.
Sir. Matt,
haven't used the rational method, again, since mainly I'm meteorology background, so I will defer to my colleague there.
Master?
These rational method is used where we cannot have a unit hydrograph because the time to travel is less than even 3 hours. Whenever the time to travel is less than 3 hours, a 1 hour unit hydrograph will not have at least 2 points on the rising limb, right? Because to define the rising limb, at least we should have it 2 points on the rising limb, so that we have 1.00 and another point time to peak and the value of peak. So we must have a time of travel or time to peak of roughly 3 hours to use the unit hydrograph method. If the unit hydrograph, if the time to peak is less, then we try to do some kinematic modeling, or in good old days we were having this rational method. Nowadays rational methods are less and less used because aircraft gives a very good method of kinematic wave routing, and the kinematic wave routing will adapt the small portion of the output from the small portion of the catchment to sum up and make the kinematic wave bigger. But even when we are doing the rational method, the time to concentration is to be derived from the various empirical formula only. There is no prescription that this formula is good or that formula is good. It is based purely on experience, purely on the judgment of the hydrologist, and roughly you can check the time of concentration derived from the various computations by thumb rules to check the velocity of water, average velocity of water, average velocity of wave that is generated due to this time of concentration. If it is in the practical limits, say like 3 meters per second in normally 1.5 meter per second in flat areas, or 4.5 meters per second in air, and like that, then we can accept the value. Acceptance is based purely on the judgment of the hydrologist only. And the impact of time of concentration is that the basin must be excited fully, because once we do CIA means we have to take the corresponding rainfall intensity according to the time of concentration. So that the basin is excited fully, and then the water that reaches at the outlet, at the point of interest, we get the sustained peak for that purpose. So that is the impact of time of concentration. If we take the time of concentration less, although intensity will get increased, but the basin is not excited fully. And if we take time of concentration bigger, its intensity of the rainfall will become less, and therefore we will be underestimating the flood.
Thank you, sir. There is a request, Mr. Kin Wa Win. Kindly mute your mic. Kin Wa Win. Kindly mute your mic. Because there is some disturbance. Master sir, your mic has been muted somehow, or is it open? because we tried to, now the person whose sound was coming has muted himself, but in fact all have been muted somehow. So you can unmute yourself?
Yeah.
Okay. The next question is whether one should go for PMF or SPF or frequency analysis approach for design flood calculation for a barrage. Guideline for design flood computation of barrages.
I will like to share 2 slides on this.
Okay.
So kindly unshare this and I will share this slide.
You can share now, sir. Yeah.
My slides are visible.
Yes, sir.
So here we do not have much of the choices, right? Because the first thing first, the design flood criteria that we talk loosely are for spillway design flood or the waterway design flood. There are other design floods, design flood for energy dissipator, design flood for upstream protection, design flood for diverse construction flood, and so many things. But we are talking only of the spillway design flood. The objective of the spillway design flood is that the water retaining structure should not fail. Should not fail means it should not go for the uncontrolled release. So the design flood prescription is mainly based only for the purpose that the dam or the barrage should not be washed away and add to the misery of already miserable people who are suffering the flood. That's all. It has got no other purpose. Many of its parts will be damaged if the spillway design flood comes. Its spilling machine may be washed away. Its some guide wall may be washed away. All those things can be taken care of afterwards. Second thing is that the design flood for dams, it is PMF, SPF or 100-year return period flood based on IS 11223. And if you are having an intermediate or large dam, there is no choice. We have to have SPF and PMF. And if you are calling 10,000 return period flood as SPF or as PMF, then you have to justify it. There is no prescription of 10,000 return period flood to be PMF as it exists in USA. So we have to go for a hydrometeorological approach where we have got the PMF or SPF if we have got intermediate and large dams. However, when we come to 100-year return period flood, there are 2 possibilities. If you have got the site-specific observed peaks of peak based on annual data, then we can go by statistical approach applied on the observed flood peak to get a 100-year return period flood or a 25-year return period flood or a check flood of 500-year return period or anything. But even in those, because most of the time we do not have even a 20-year or 30-year data, flood peak data available. So even in even in the 100-year return period flood, we sometimes go by hydrometeorological approach, where we take a 100-year return period design storm or a 25-year return period design storm or a 500-year return period design storm, and then convolute it to unit hydrograph to get a 100-year return period flood, or 500 return period flood, or a 25 return period flood, as the case may be. So wherever there is a return period flood prescription, we have got a choice whether we go by a hydrometeorological approach or we go by a purely stochastic approach. But where the prescription is SPF or PMF, we do not have any choice of going by stochastic approach in India. In other countries, there are equivalents given, but here we do not recognize the equivalence. So this is about dams. But if you go to barrages, in barrages, the code applicable is IS 6966. And the IS 6966 prescribes a 50-year return period flood for the waterway and 500-year return period flood as a check flood for freeboard. So then there are other structures also like CD bus. There is a IS code IS 7784. There are diversion during construction which is based on 10084. 1982. If it is a road bridge, then there are IRC classifications. So every structure has got its own prescription of design flood under various codes, BIS codes, IRC codes, railway codes, and so many codes. And we can have different design floods, different types of design floods using either hydrometeorological approach or the stochastic approach. Thank you.
Thank you, sir. Thank you very much. If you unshare, then I can share the questions again.
So has it been unshared?
Yes, yes. So the next question is, in semi-distributed modeling, there was a point that URBS can be used as an event-based model that requires the user to input the rainfall loss to the basin or sub-basin before the runoff occurs, or it may be run in a continuous mode and coupled to other third-party runoff loss models. In this regard, how can we measure the rainfall loss to the basin sub-basin before the runoff occurs? Sir, Matt sir, would you like to take up this question?
No, I'm going to pass on this one.
Okay. Sir, Mathur sir, will you take this question?
I won't go into the modeling part, but I can say that the loss rates are only based on the prescription. There is a green empty model of assessing the loss, and in many of the models, the green empty model is built in. So even HMS also some version it was built in. I don't know the present position. So it is built in, and we do not have to take care of this. If it is asking a loss rate, then we should give a loss rate of say 1 mm to 5 mm per hour, which depends on the area in which you are there, whether it is the first flood or second flood or third flood. Because in first flood there will be a larger loss. In subsequent floods there will be smaller loss and all those things. But they are all based on the prescription only. There is no way one can find out how much loss is there or how much loss will be in the what we call pre-event loss.
Right. So, thank you sir very much, and I will stop sharing this screen because we have received these questions. We have this inventory of questions. Now we can take up the questions by the participants. If someone wants to raise any query related to modules or climate related module which was initially requested, anybody can ask the question or write in chat box. We can take up from there. Anyone wants to raise any question? So I think no more queries are there.
Sir, I have one question.
Okay, please.
So my name is Sunil Kumar. I'm from Karnataka Water Resources Department. My question is regarding the final assessment in the subject. Mathur sir has given some points about that. It is about the rain gauge density, rain gauge station density.
Right.
So basically what I'm planning to do is, in Karnataka, we have about more than 1,000 rain gauge stations. So here I just want to see, are they in par with Indian Meteorological Department standards in plain area and in the Western Ghats area? So any suggestions on that, sir?
What I have understood from your question is that you want to assess whether this density is sufficient or not.
Yeah, exactly.
No one can say. No one can say that this adequacy is sufficient or not. It is you who has to justify that I have covered mostly these ring gauge stations. There is very less variation between this ring gauge station and that next ring gauge station. They are very much reasonable. If I find that while you are averaging out the rainfall data, and one ring gauge station is showing 300 mm rainfall, and another ring gauge is showing hardly 25 mm of rainfall, then I have got a reasonable amount of doubt that the rainfall pattern is not getting captured by your ring gauge station. And if it is a 300 mm surrounded by 250 mm, surrounded by next 200 mm, surrounded by next 150 mm, then I consider that this is catching up the rainfall pattern. And if we talk of the Western Ghats region, no amount of ring gauge stations can be sufficient, because rainfall pattern is varying every square inch of the land because of the orographic pattern. It may be very high rainfall at one particular point at one particular time, and very low rainfall at another particular point or particular time. So as Matthew has suggested, if there are some radar products, then only we can be of some assurance that this rainfall pattern is getting caught up. TRMM project has ended. I think some TRMM 3 is coming out. If we want to depend on the open source foreign products, or the PRISM is also coming. So some sort of radar products can be there, but it will be of high, you can request IMD, or if because Karnataka WRD is very active and a strong department, it has got a great DEN 50 unit also, as I personally know. So Karnataka Water Resources Department can have its own 2 or 3 radars at the ridge which cover the entire area in their basin. That will be of great help to themselves and to the hydrological community in the country also.
So Sunilji, is it okay, or you want to ask something more?
No, sir. Sir has covered most of my doubts. Thank you, sir.
Just like to supplement what Mathur sir has said, because we also say that Central Water Commission has a flood forecasting services throughout the country, and the adequacy of rain gauge station network is always an issue. And with the increasing variability and the evidence of localized rains and cloudbursts, the need for having more and more denser network of rain gauge is always felt. As said by Matt, that the radar is very useful in giving you a complete aerial picture of the rainfall that is happening. However, in India, IMD has only limited coverage of the radar as of now. I think recently they have started one more program in which about 45 radars are going to be installed all across the country, covering almost major part of the country. Once we have those radar networks in place and the radar products will be available on IMD website, then probably we will get a better picture of rainfall all across the country, particularly in the area where we require those data for rainfall runoff analysis or for flood forecasting. So probably in the next 3-4 years time, that is the time span in which this IMD is planning to put up this radar network. Maybe in the 3-4 years time, we will have a much better coverage. Coverage similar to what we have right now for USA, for Europe, or for Japan, or for the advanced countries.
Thank you. Thank you very much, sir. Any other queries? Is that all?
I think I would request foreign participants who have joined, international participants who have joined this webinar. It's really heartening to see that many of the international participants are also present in this webinar. So if there are any queries specific to their country or specific to their local situation, they are most encouraged, most welcome to raise the queries. International participants, you can unmute yourself and speak, or you can write the question in chat window. I think there is no question. Anish, you can go ahead.
They had already shared whatever they had. Maybe they don't want to speak as yes.
Okay.
But we are always open, and in course forum, as in chat box here, or through SMS, you can always raise your queries and any information related to this course. We will try to help you all, whatever possible. Sir, to conclude, I would request Matt sir, Shastra sir, and Master sir to say a few words because we are coming to an end. Matt sir, would you initiate the concluding part?
Again, thank you for your attention and your efforts during these last 5 weeks, and I wish you good luck in finishing whatever quizzes you have remaining and the final assignment. Don't hesitate to reach out to us if you need any assistance or have any questions you want answered. And I hope you found this a good learning experience, and it's always fun for me to see these modules, at least the ones that were developed at Comet, getting used. They were developed, some of them almost 20 years ago, as I said, when I was working with a team of hydrologists to do those scientifically correct. I put them together, but I had people helping me with the information that went into them. So I get a lot of enjoyment watching these get used by so many people, and I hope you did find them useful. Good luck, and I look forward to reading your assignments. I always learn a lot from people in different countries when I read those.
Thank you, sir. Thank you, sir. I would request Master sir to say some concluding remarks.
It was a good opportunity to interact with the participants and get the insight of how they think of the subject and the problems from their point of view. So it was a good learning experience for me, and the level of questions that were asked show their understanding, that they have understood the topic and trying to apply to their field where they are working. So that is how they came up with these questions, and this is good to see that the course is getting deeper into them, and I congratulate for them, and I also thank National Water Academy to provide the forum where I could interact with them. Thank you.
Thank you, sir. Thank you very much. Now I request our head of academy, D.S. Shastri, sir, to say some concluding remarks.
This an hour of interaction, or more than an hour of interaction, was really enriching, very enlightening. The questions, level of questions that was being asked indicates the interest shown by the participants, modules and content of this program. In fact, as Mathur Sahab said, these questions were of a little bit of advanced type. And indeed, we will be conducting an advanced version of this course sometime later. And when we conduct this course, the officers who have participated in the basic course, they are eligible to participate in the advanced course. So do keep an eye on the website of National Water Academy to see when this particular course gets scheduled. And I'm sure you will have many more insight into the advanced topics. I must thank Mathur Sahab and Matt for joining and sharing their expertise. And I also must thank all the participants who have joined today, Indian as well as international participants. The recording of this 1 hour interaction will also be available on the course website because even around 50 participants have joined today live, and we have about 135 participants in this course. So the recording will be accessible to everybody. Even some of the participants who have joined may have missed something. They might have joined late, or they might have missed some answer. So they can always refer to the recording again. And I would request Pandeyji to put a recording on the course website as soon as possible. And lastly, I would congratulate all the officers who have completed the course activities as per the schedule. And now only final assignment is by balance, and I'm sure they will also do it. Please submit your final assignment as early as possible so that we get time to evaluate it and give you feedback about your assignment. And those officers who are slightly lagging behind for a few modules, they are also encouraged to complete it as earliest, so that and also submit the final assignment so that we review it, assess it, and we conclude the course as scheduled with a concluding webinar on 21st of November. So thank you once again for joining to the faculty, expert faculty, and also the participants. Thank you.
Thank you, sir. And last, it is my honor that Mathur sir has been our mentor for all our efforts, for all NWA's efforts. It's a kind of, his presence is kind of blessing, sir, for all of us. Thank you, sir, very much. And I will keep troubling you in future also. Thank you, sir, very much. I would also.
It is always pleasure to work for NWA.
Thank you.
And the young participants.
Thank you.
It gives us energy.
Right. And I would also like to express my heartfelt gratitude to Matt sir for being a pillar of strength for this course for almost a decade. Thank you, sir, very much for being present at very odd hours for you, particularly being here. Thank you, sir. And in the last, I would like to express my heartfelt gratitude to my own head of academy, Dr. Shastri sir, who has been the initiator of this course in India in 2012 and who has been constantly supporting me, whether he has been in NWA or outside NWA. Thank you, sir, for being here. It has been an enriching and very fulfilling session for all of us. Thanks, and thanks to all the participants who spared their valuable time during their office hours and came here and attended this webinar. We are, as Shastri sir told, we will place this recording in the course website. Thank you very much and good day.
Good day, sir.
Thank you. Thank you.